to be a bit less flashy because it's more about a data storage backend. I'll try to increase the size. I don't know, maybe people are familiar with this, but this is the XNAT storage platform, which is being used for clinical and preclinical data. It's mostly for MR-CT data, things like that. It's a research storage system, so data is stored into projects. So this is actually one of the servers that we have running that contains 160,000 imaging sessions. These are stored under subjects, and then we have scan sessions under that. In this case, for example, MR scan session. So this is how the system looks if you would go through the web interface, and you can actually then look at the data, browse through it a bit. But it also has an API, which actually allows you to talk with this archive via a REST interface, which is via the network, which is very useful to, for example, batch download or upload things, but it's a bit tricky to use. So for that, we made a Python package, which actually helps you to do this. And the main goal for this was actually to create a package which makes it as easy for people who are used to Python and some data science to be able to work with the data, which is on a central server, and to manage it well. So for that, we created an XNATpy package. You can simply import it, and you can actually make a connection to the server. So if you look in the browser, this is actually the URL that I was showing you the web interface from. And if I connect, it actually makes a connection. What is the thing what makes it special is that XNATpy wraps the data model of XNAT into native Python objects. So for example, if you go to the connection and ask for a list of projects, it gives you a listing of all the projects, and you can actually just loop over it like it would be a normal list. I can select actually also a project by its label. And if you have the project, you can query like different parameters, like what's the name of my project, and you will get it back. Like it will be just, it looks like it's almost normal Python code that is running locally on some objects, but in fact, it does everything via the internet and retrieves the data from the server. So if you have a project, you can actually get a subject list again. This is a smaller project. And again, you can transfer through that. You can ask for the label. You can go down this whole list. So this makes it really easy for data scientists to interact with this archive. And this is mainly meant for people who can program, but are used to using Python and maybe something like Pandas to manage some data, but are not very familiar with like REST APIs, internet technologies, and are not actual engineers. So the listings that we have, for example, we made it so that it actually acts quite a bit like a list, both list and a dictionary. So you can actually look at the experiments. There's actually only one experiment here, but you can actually retrieve it by either the label, the ID, or by the index, and it all is valid in this case. Now, if you have, for example, an experiment and you want to download it, it is actually as easy as selecting the correct experiment object, and it has a .download, and it'll actually download this whole experiment. This should take a little while. As you see, there's a progress bar because it's going to download, I think, something like 100 and something megabytes. MR scans are not too small, but as you can see, it's now downloading. And then once that's done, I should be able to check the directory in which I downloaded, and it should have appeared. So actually here, it just downloaded it, and you can see the timestamp that I just did that. I'm going to skip the pre-archive because currently it's actually empty. I don't have anything in there, but also you can manage a pre-archive. There's some other interesting features that we have. You can actually open files on the server in such a way that it looks in Python that you're working with a real file. So if we just select one of the scans in our experiment, we can actually just open it with a simple file object open, and we can actually read the data, and we can actually do partial reads. So we just read the first bytes of a DICOM file, and you can actually see that it has the magic bits in here, and here it actually starts showing the UIDs that are common in DICOM. So what we can actually do, we can also read the DICOM header that way. So for example, we can very easily read the entire DICOM header without having to download the whole data. And you can actually work in it from IPython notebooks to do easy things. To make it easier, we also have some more advanced functionality. For example, we have a mapping function. This actually is like a map which you would work on like in Python, where you have a map, so you apply a function to a list of objects. In this case, it will apply the function of your choice on objects in the archive at a certain level. To illustrate this, for example, if I have a small function which basically returns a bit of data about the object, I can map it. I will say at which level I want it. So I want to map it for all experiments that I have access to. I can actually also add a filter to it. So basically, I only do it on projects for which the ID matches sandbox. And if I would do that, this automatically goes through the archive, finds all the matching objects, and performs that function. And here it actually has the URL of the object which it applied to, plus whatever the function returned is here. So that's actually somewhat to do powerful batch operations. Also, we have a sort of search, which is based on a similar system. This is actually a client-side search. So if you, for example, want to search for all the scans in the project sandbox, but the experiment has to match, has the string anon in it, and the scan has T1 in it, we can run that, and it actually goes through the archive, traverse it. This does it client side, and actually will find all the matching things very easily for you. This can, of course, for a large archive take a bit of time, because it actually has to go through it. That's the downside. The upside is that you actually can do also regular expressions, for example. So you can do actually advanced matching. XNAT comes with a server-side search. That's a bit different. We implemented that in a sort of an ORM mapper style. So basically something similar to SQLalchemy. So you can actually select a class that you want to query, and then you can actually add filters to it. So in this case, I query for MR session data objects on the XNAT archive. And I say that the project of the MR session data has to be sandbox. This is actually then sent as a query to the server. The server actually does the actual querying, and then we get the results. So this is actually faster if you have to query a lot of data, but you are limited a bit in the way you can match things to what the XNAT search engine allows you to do. You can actually also combine multiple filters or constraints. So for example, here I can actually select only the ones that have anon in their label. I can do the same by chaining filters rather than to use an AND operator. It will do the exact same thing. And finally, instead of just asking for all the objects that match, we can also, for example, say we want to have it tabulated as a CSV. So this actually gives us a CSV response. Or for example, I want to turn that CSV into a pandas automatically. So you get like a table of all the experiments that match very easily. So this library is to make it very easy to interact with that. And it's actually meant for other people to build their tools and scripts on top of it. So, I mean, you can do almost anything with it. And it handles for you like the login and abstracts away a lot of data model. So that's very good. And to have a very quick illustration of that, this is actually made from another university that I know of, and they told me about this tool. So they actually made a browser, which is just, I hope it's readable, but they made a sort of a GUI based on that runs in the command line interface, and in the background, all this data querying is actually done with XNATpy. So you actually can browse through the archive. So this is very similar to what you saw on the web interface, but it actually renders faster, and especially for very large data sets, actually is more efficient. And for example, I could now, if I select the DICOM image, I can query the tags, for example, and it will give you the entire DICOM header here, for example. And actually, they made it so that you can even see like a sort of preview of the actual scan in here as well. This is all text-based, runs in the command line, and is built on top of XNATpy. So it shows you that you can actually build a lot of nice things on it based on this library that we created. And that's it. I mean, we have it on GitLab. It's open source. You can find the documentation on Read the Docs.